Hi, I am Michael Wang, and today I will be going over the USACO problem that occurred in 2020 December bronze contest, problem number 3, which is called Stuck in a Rut. Let me share my screen. So this is the problem, and so let's read the question first. And actually, in case you're wondering, I had Windows 11 installed on my computer, and the GUI looks kind of different, but yeah. All right, I digress. So let's go back to the problem here. It's on the screen, and so let's read it. Farmer John has recently expanded the size of his farm, so from the perspective of his cows, it is effectively now infinite in size. The cows think of their grazing area of the farm as an infinite 2D grid of square cells, each filled with delicious grass, and think of each cell as a square in an infinite chessboard. Each of Farmer John's N cows, where N goes from 1 to 50, they start out in a different cell, and some start facing north and others start facing east. Every hour, every cow either stops if the grass in her current cell was already eaten by another cow, or eats all the grass in her current cell and moves one cell forward according to the direction she faces. And so over time, each cow therefore leaves a barren rut of empty cells behind her. And if two cows move onto the same grassy cell in the same move, they share the cell and continue moving in their respective direction in the next hour. Determine the amount of grass eaten by each cow. Some cows never stop and therefore eat an infinite amount of grass. And so the input will have the first line containing N, which is how many cows. In the sample input is 6. And each of the next N lines describes the starting location of a cow in terms of a character that is either N for north facing or E for east facing, and two non-negative integers X and Y, each between 0 and 10 to the 9, and which give the coordinate of a cell. And the X coordinates are distinct and the Y coordinates are distinct. And so for clarification, but we don't need clarification. And so here's the input. So we have 6 cows. The first cow faces east and is at 3,5. The second cow faces north and is at 5,3, etc. And then for the output, oh, by the way, it's from the input and output are from the terminal, which is standard in and standard out, because it's in 2020, and so we're using the new system here. The output will print out N lines of the output, and the ith line describes the number of cows in the ith cow of the input, the number of cells that the ith cow eats, and if it eats an infinite amount of grass, we output infinity. And this is the output for the given input. All right, and so I encourage you to try it out before you continue to see my solution. And at any point in the video, if you feel inspired, feel free to pause and see if you can complete the problem. Also, I know that there are many videos on YouTube about this problem because it is pretty hard, to be honest. And there's even the USACO even had a official solution over here. So if you want to read it, you can read it. But I think my solution is a bit different from any of the solutions that are currently out there. And feel free to check out the other videos and the official solution if you want to. And I think this is actually one of the hardest problems in USACO problems. Probably not the hardest, but it's definitely one of the hardest. Definitely in the top 10. I think the main reason is because the numbers are very big, 10 to the 9, and there are 50 cows to stimulate. And so for USACO, the number of operations that the grading server can handle is on the order of 10 to the 8th. So often in the USACO bronze, you can actually just directly simulate the problem and you can patch all or almost all the test cases. However, in this case, you cannot do direct simulation. It won't get you far because it will it is 2 to 3 orders of magnitude greater than what is allowed. Actually, if you want to try out direct simulation, you can go ahead and see how many you get correct. It didn't time out because for Java it is 4,000 milliseconds. For C++, it is 2,000 milliseconds. So that's why you might time out. So clearly a smarter algorithm is needed to solve this. All right, so how should we solve the problem? Since we have the sample input, let's just actually just simulate it by hand just to get some intuition for the problem. So let me get it open. Okay, so I currently have it right here, right? And east is red, colored red, and north is colored green. And then for each subsequent step, I will use orange and blue. So for orange for the east cow and blue for the north cow for in the future for more time steps. And the axes are in increments of 1. And the cells that are eaten are marked with color, where cows have eaten, and cells that are not will not be marked with color. Okay, so let's do it. Let's see, right? So the first cow is eastward, so I labeled it with a 1, and it's at 3,5. The second cow is northward at 5,3. The third cow is eastward at 4,6. The fourth cow is eastward at 10,4. The fifth cow is northward at 11,2. And the last cow is northward at 8,1. So I think I have them all correct. All right, so let's see. Now, this is at time t equals 0. We have this configuration. What happens when we move forward 1 second later? I mean 1 hour later. Then cow number 1 will be at this location. Cow number 3 will be at this location. Cow number 4 will be at this location. Cow number 2 will be at this location. That's not too good. Okay. Cow number 5 will be at this location. And cow number 6 will be at this location. So that's 1 hour later. Okay, that's good. So now let's see another hour later. Right? I'm gonna use a different shade. Let me yellow. So cow number 1 will be over here. Cow number 3 will be over here. Cow number 4 will be over here. Okay, and I use purple. Cow number 2 will be over here. They will both share this spot because they said that if 2 cows move onto the same grassy cell in the same move, they will share and will continue moving in the next hour. So cow 1 and cow 2 will share this location. Cow 6 will continue moving. Cow 5, well, it blocks, right? So let's see, let's reread the problem again. What it stops if the cow in her current cell. So it will move over here, but it will not be eating anything. So it will only have eaten 2. So it will only have eaten 2, this and this, and it will stop. So cow 5 has been stopped. So I will. So now cow 5 has the cow 5 has stopped, and it has eaten 2 grasses. And so look right here, cow 5 has 2, right? Okay. Now for the next time, right? Let me use this. Cow 3 will continue. Cow 2 will move over here. And cow 1 will go over here. Cow 4 will go over here. Cow 2 will be blocked by cow number 3. And pick a suitable color. Not too important, but so cow 2 will be over here, but blocked, right? And so cow 2 will have eaten a total of 3 cells 1, 2, 3. And so it should be 3 over here. Yep. Okay. Cow 6 will be moving over here. And cow 5 was blocked, so we don't worry about that. Alright, now for the next time, cow 1 will move over here, cow 3 will move over here, cow 4 will move over here. It appears cow 4 will not be stopped by anything else because it will keep going on. So I think we can just call cow 4 infinity, right? It will not be blocked by anything else. So we're going to call cow 4 infinity, and yep, it is infinity. And also, we can also call cow 3 infinity, because it will not be blocked by anything else. It cannot be blocked by 6 or by 5. So it's basically infinite, and that's good. And wait, cow 6 haven't moved the steps yet. So cow 6 will now be over here, right? And then in the next hour, cow 3 and cow 4 will just keep moving. So we're not gonna worry about them anymore. Cow 6 will be stopped over here. Cow 1 will already be stopped over here. So how many did cow 6 eat? Cow 6 will have eaten 1, 2, 3, 4, 5. That's not good. I just... Okay, so cow 6 will have eaten 5, and cow 1 will have eaten 1, 2, 3, 4, 5. So cow 1 will have also eaten 5. So let's take a look. Yep, cow 1 is eating 5, and cow 6 is eating 5. Cow 2 is 3, cow 3 and 4 is infinite, and cow 5 is 2. Yep. So now we have a bit of an idea about how this problem works. Okay. Now, if you want to, you can pause the video and try to program it out. All right. So one key fact, in order, if you want to get it all correct, let me do this. Okay. So one key fact that you should notice when we were simulating, right, is that as time goes on, how do you do this? Is that right? I think that's right. Yep. Okay, so one key fact that you should notice is that as time goes on, the X position plus the Y position plus, right, will always be equal to the X position and the Y position at any given time, any given moment in time, will be equal to the original X plus the original Y plus however many hours that pass, right? So right here, this cow is at 3,5. After 1 hour, it's 4,5, 5,5, 6,5, 7,5, right? I think it stopped over here. Yep. So at any given moment, it will be the initial X and Y location added together plus the time. Same with, it doesn't matter if it's moving in the X direction or in the Y direction, it will always be the case. So it will always, this will always be true. Unless it is blocked, right? If it is blocked, then it will not change, right? So what this means is that the value of X plus Y will increase by 1 each hour. And another thing you need to note is that the relative difference of the sums of the X and Y coordinate for each pair of cows will be the same at any instant in time, provided that the cow is not blocked. If the cow is blocked, then we don't have to worry about it. We already got the answer. All right, so now on with that information, try to pause the video and see if you can program it out. All right, and if you get stuck, here's another hint that might help. which is that, okay, so let me undo all these. Can't undo. All right, then I guess let me open it again. Like this. Okay, so this cow has the largest X plus Y. Cow number 4 has the largest X plus Y, right? Cow number 1 has X plus Y is 8. Cow number 2 is X plus Y is also 8. Cow number 3, X plus Y is 10. Cow number 4, X plus Y is 14. Cow number 5, X plus Y is 13. Cow number 6, X plus Y is 9. So cow number 4 has the large X plus Y. Oh, wait, X plus Y, what does that even mean, right? So basically X plus Y, since this is a constant, which means, which indicates the diagonal line, 45-degree diagonal line. These 45 degrees, I can't draw with my mouse, but these 45 degrees diagonal lines, so there will be progression along these lines, right? So let's see cow number 1 and cow number 2, right? They're both on this line, on this diagonal line, right? Let me see. I think, all right, that will have to do. And then after the next moment, cow number 1 will be over here, and cow number 2 will be over here, which means that it will both will be on this diagonal line. So it will always, and the next instant will be on this point, which means it will always stay on. That was not so good. Where's my mouse? Okay. So note that it will always stay on these diagonal lines right here, right? Because I am focusing on the value X plus Y. Okay. And so that's the next key insight. And note that the cow with the largest X plus Y will never be blocked by anything else, right? This cow will not be blocked by anything else, right? Because it has the largest X plus Y, and it will remain the largest X plus Y. So right now, its X plus Y is on this line. The next instant, its X plus, since it's moving to the east, it will be on this spot. So it will be on this line. And next moment it will be on this spot, so it will be on this line, etc. Right? And this cow will never go be. So let's take a look at this cow. This cow will, at this moment will be on this line. Next moment will be on the next line, and be on the next line. And it might be blocked. It might not be blocked. Right? And we need to check. And if 2 points, for example, 1 and 2, are on the same diagonal line, they will not block each other because they will reach the same square, right? They have the same X plus Y value, so they will reach the same square at the same time, and they will not block each other. All right, so pause this video and try to program it out. And next, I will be programming out. I'll be showing you how to do it if you get stuck. All right, and in this video, I will use Java to program everything out. And in this case, my IDE will be IntelliJ, but I will be using C++ and in Python. And I will be linking those code in the description below if you want to see it. I will use the same method. It will be exactly the same code as close as I can make them. But like it will be with the same method. All right, so let's program file new project. All right, I don't need to change that. Project name, USACO homework. Let me add a new file. 2020 December branch problem 3. Okay. And finish. Okay. All right. Source new Java class, and I just call it. I don't know. I just call it something random. Okay. All right. So let me see. So here's the problem, and so I will be using that idea to, and I'm pretty sure at this point you're probably just going to click on the. You're probably going to skip forward. Go ahead. Okay. I can't seem to find it. Okay. All right. So I got it. Now we can start programming, right? All right. So what we need to import java.io.star. I'm just gonna import everything. And okay, so actually I just typed main and I pressed tab, and so that's what it did. Okay. All right, and we also need a. All right, so let me set up the input and output. Uh, and by the way, the USACO guide recommended to use buffered reader and print writer because that would be quicker than the standard input and output. So I just use buffered reader br. If you could new buffered reader, new input stream reader system.in and print writer. Oops, new print writer, new buff, buffered writer, new output stream writer, system.out. Okay. Now we need to read in the input, right? So we need string tokenizer, new string tokenizer, buffer reader dot read line. Oh wait, right. I need to throw input output exception. All right, so let's go back to the problem. All right, so the input contains n, and then we have the count, right? Which is a character, x position, and y position, right? Okay, so integer n is caps lock. Right, and then so I get the n. Okay, now I need a cow class, right? Because we have many different cows and they each have the attribute of direction, x and y, right? I think it would be easiest if we added a cow class. So let's do it. All right, so we have character direction, integer x, integer y, integer distance traveled, distance traveled, or grass eaten. Okay, and I just get an integer ID, which is basically the which cow it is that we input it in. The first cow will have an ID of 1, second cow will have an ID of 2, etc. So that will help us when we get the output. Now let's initialize. What do we need? We need ID, direction, okay. All right. So how much grass is eaten, right? So initially, I will assume that each cow eats an infinite number of grass, but like obviously since it's an integer, I can't do infinity. But we can see that the maximum that it can eat is 10 to the 9, right? No, from 0 to 10 to the 9. So the maximum that a cow can eat grass without being infinity will be 10 to the 9. So I will equal to 1 plus 10 to the power of 9. And then so if the graph eating is this, then I will output infinity. And if it is not this, then I will output the amount of grass eaten. Okay. So actually, let me do the toString, which will be out the how much grass it can eat. So if this dot grass eaten is equal to 1 plus integer equal to 10 to the power of 9, then return infinity. Else, actually I don't think I need else. Actually, I just do it just to be clear. Return. I will convert the integer to a string. That's it. So because it's an integer, but it returns a string, so I have to convert the integer to string. All right, now I will do my getters. Okay, and now when we remember what we did, our entire logic hinges on this x plus y thing being the relative difference of x plus y for each cow that is not stopped is invariant. That was how our entire logic was based. So it will make sense if we just do a x plus y, right? Get x plus y. Let me put on parentheses just to be clear. Okay. All right. And I think that should be good for now. All right, let's go back. So we get in our n, right? And now we need to get our cows from the input, right? From the terminal input. So how should we do it? Let me use an array list. That would be quicker. And the size will be n. And for the I is equal to 0, I is less than n, then I will get the next line in the string. So I will just copy this. I'll get the next line. String tokenizer will grab the next line. And I will add a new cow, right? So cow list dot add new cow. Now let's get the attribute, which is I plus 1. Okay, that would be the ID. I parentheses on it. That would be cow ID because I started from 0. So actually, let me just do this. So yeah, I don't need that. All right, so start from 1 to n. So that actually doesn't really matter if it. But all right. Anyway, so next I will get the direction. So next token dot child character at 0. So I get the next character. With the next attribute, which is the x, and the next attribute is the y, which are both integers. So I just copy and paste this line. Okay. Oh, that's nice. All right, so I think that's good. There. Okay. So there, I got all the cows, right? All right, now we need to sort the cow list by the x plus y attribute, right? If the x plus y is greater, we will deal with that first, right? Because it will not be blocking anything, right? I mean, it will not be blocked by anything, right? The greater the x plus y, the greatest x plus y will not block anything. However, it will block other people, right? And then, so, all right, let me go back to that picture. Why is my mouse not cooperating today? All right, draw. Okay, so this dot has the greatest x plus y. It will not be blocking anything, right? This dot, which has the second greatest x plus y, it will only be blocked by this count, right? It will only be blocked by count number 4. Right. The next greatest x plus y will be count number 3. It may be blocked by count, cannot be blocked by 4 because it's going in the same direction. It may be blocked by count 5 if count 4 were not there. But count 4 is there, so count 3 will not be blocked, right? Count 3 will not be blocked by anything because count 4 blocks count 5, so count 3 can go free. But if count 4 did not block count 5, then count 5 will block count 3. So that is why I had this graph using parameter. And so in count 5, after we deal with count 4, which will be this infinity. Next we will deal with count 5, which will be blocked by count 4. So this now its graph region will be equal to 2. Then since count 3 will not be blocked by count 5 anymore, it will be infinite. So that's my reason. That's the reason I did that. All right, so now let's program it out, okay? So I will now sort this array list by the x plus y attribute. So cow list dot sort cow 1, cow 2. I'll use the comparator and I will sort it by that compare because it automatically sorts from smallest to largest, but I wanted to sort from largest to smallest. So cow 2 dot get xy, get x plus y, comma cow 1 dot get x plus y. So now it will sort from the largest x plus y to the smallest x plus y. All right, now let's take a look, right? So okay, all right. Now let's run it and let's prove that it works. Oh wait, I didn't have my input file. Okay, so what was it called? Well, no. So I'm gonna copy and paste into the terminal. Okay, so now it sorts by the largest to smallest, and let me also put up get get ID tab. Okay, so it will first show the ID of the cow, and it will show the so cow 4 has an extra drive 14, cow 5 has an extra drive 13, cow 3 has an extra drive 10, etc. And it is sorted by the ID by the extra Y value, right? And we don't care about duplicates because we know that, as I said before, that they will not interfere with each other. All right, so now we got that out of the way. I can delete that. Okay, so now I've sorted it by x plus y. Now for in I equal to 0, I select then calculus dot size I plus for j is equal to 0, j is less than I, because I will only need to compare with cows before. So that's why I did j from 0 to I, 0 plus. All right, actually I get to cow 1, cow 2. Cow 1 will be the cow at location I, and cow 2 will be the cow at location J. Semicolon there. Okay. Cow 1 is equal to cow list dot get I, so get the I cow, and cow 2 is equal to cow list dot get J. So cow 2 will be the J cow, right? Okay. Now if two cows have the same x plus y, then we don't need to worry about it anymore, right? Two cows, these two cows have the same x plus y, we don't need to worry about them anymore. So if cow 1 dot get x plus y is equal to cow 2 dot get x plus y, great. All right, so we don't need to worry about them, but if we have a lot of different 8s, and then we have a 7 down there, we don't need to worry about each 8, right? Because if we have, let me actually file, it's a random file, okay. So we have, let's say we have 14, 13, 10, 9, 8, 8, 8, 8, 7, 6, 4, right? All right, so now if we're at, say, this 8, right? We check with 14, check against 13, check against 10 and 9, and now we have an 8. Now we don't need to check these guys anymore for this 8, right? Because they will all, like, they will get to the same spot and they will be gone, right? So we don't have to worry about them. And now so we can break because we can't access these from when we're like before, right? And but when we're at 7, then we will need to check against every single one of these 8. And so that's why I did that. So now, so that justifies why we can break. Let me add a comment just to be clear. Okay. Now, if two cows have the same direction, right? if two cows go in the same direction, they will never intersect, right? Two cows go in the same direction, they will never intersect. They will only intersect if they have different directions, right? So now, if cow 1 dot get direction is equal to cow 2 dot get direction, then break. Actually continue. We're on to check the next cow, right? If they have the same direction. Okay, so now next we need to check if they cross, right? If they cross each other, right? How do you check if they cross each other? Well, if I'm going east, right? Let me erase all these marks. Okay. If I'm going east, and my y position, my y position is greater than their y position, right? Then we have a probability of crossing, right? But if I'm going east, and my y position is smaller than the northwards y direction, then we will not have a probability of crossing, right? Same thing with if I'm going north, right? If their x position is greater than my x position, we might cross. If their x position is smaller, then we will not cross, right? So let's code for that. If not check cross, it will be have two parameters, cow 1 and which is itself, right, and cow 2. If they don't cross, then continue, right? Cow 1 is greater than cow 2 plus eating distance. So no greater than cow 2 location. So no block. All right. So now let's add that public integer boolean check cross cow another cow C, right? If I'm going east, if I'm going east, right, and my y position is greater than or equal to their y position, then we have a probability of crossing, right? And else, which means if I'm going north, and my x position is greater than or equal to their x position, right, then we also have a probability of crossing, right? Else, then we will not have a probability of crossing and they will return false. And if we don't have a probability of crossing, then I will continue. I will go check the next tab, right? All right, so now, okay. So now we got that out of the way. So next we check if they will block each other, right? How do we check if they will block each other? I think that's good enough. So let's say this cow is going north and we have this cow here going east, right? How do you check if they cross? If they block? If my cow is going east and there's another cow going north, right? And my y location is less than their y location plus however long it might move, right? Which is it's grass eating, right? If it can eat all the way up to here, and then I might be blocked, right? It's not guaranteed, but I might be blocked, right? Well, of course, if this cow is blocked by some other cow, then I will not be blocked. Otherwise, I might be blocked, right? Actually, I put that a bit too close. Okay. But you get the idea. And if I'm going north, and there's another cow going east, right? we already checked if they have a probability of crossing now, and this cow is moving over, and I'm moving to the north, and it gets stopped over here, then I might be blocked by this cow, right? Otherwise, I will not be blocked, right? If this cow ends right here, then I can go on forever. Well, until some other cow blocks me or something, right? But yeah, so that will be the next piece of logic I will program. So if they don't block, then I will continue. Right? They won't block, right? So I will continue. And why is it not blocked? Because cow 2 is blocked by another cow. Okay. So now let's go program check block, right? And of course I have another cow. All right, so how will this logic work if I'm going east? If I'm going east, right, then I will return this dot get y if my y position is less than their y position plus the distance, grass region, the distance it will move, then I will be blocked, right? Otherwise, I will not be blocked. And I will, else return this dot get x is less than c dot the x position plus however much grass it will eat, right? All right, so that's to check if they block each other, right? And the next, if that they don't block each other, then I will adjust the distance, right? Cow 1 is the cow we're checking, and cow 2 is all the cows that came before it. Right, set distance, cow 2. Right, and I need to program that. So change distance of cow 1 based on cow 2's location. Right, just attributes. Okay, so now I will public void set distance cow C. If I'm going east, right, if I'm going east, then my distance will be equal to the minimum of my original distance. If I'm going east, right, then the distance I go will be equal to the minimum of my original distance plus the y coordinate minus my y coordinate. I mean their x coordinate minus my x coordinate. Right, if I'm going east, and there's a cow right here going north. That's a bad line right there. Okay, then my distance, I might be blocked by some other cow, right? I don't know. Yeah, right. I might be blocked by some other cow, but it will be equal to the minimum of my distance and their distance, right? And this distance from their y coordinate minus my y coordinate, right? So this distance, the minimum of distance, not distance, it's grass region. Okay, and the yeah, my variable names are not good. And their x coordinate minus my x coordinate. Right, their x coordinate. Right, and if it's going north, if I'm going north, then it will be the same thing but for the y coordinate, right? So their y coordinate minus y coordinate minus my y coordinate, that will be the limit to how much grass will be eaten, right? Their y coordinate minus y coordinate, that will be the limit to how much grass will be eaten. Okay. So yeah, all right. So I think that's good. And I have the two strings, right? Okay. So now set distance. Okay. Actually, it should be probably be set grass eaten. Okay. Now we need to go print it out, right? But the problem said, I don't think I need that anymore. Problem said is to print it out. The ith line of the output describes the number of cells worth of grass that the ith cow in the input. So that's why I did the ID thing, right? That's why I did the ID thing. So I know that if the to compare the ID, right? I need to sort the by ID right now. Now that I got all the distance, right? So let's sort this. College dot sort C1, C2, integer dot compare C1 dot get ID, C2 dot get ID. Wait, what? Can be replaced more concisely. I actually never seen the syntax before, but all right. So now let's print it out. That I prefer this syntax, but now that I sorted it, now for cow C in cow list, right? Now they're sorted by ID. Now I print out the information, right, which is this toString, which is if it's still infinite, right, I'll put infinity. Else I'll put however much grass it has eaten, right? And now I close, and that's it. 80 lines of code, and that's it. Okay, so now let me try the test case to see if it's correct. Run. Yep, there we go. It's correct. 5, 3, infinity, infinity, 2, and 5. All right, now let's take a look. Let's see how many test cases I can get correct. All right. All right, looks pretty good. So for Java, the time limit is 4,000 milliseconds, and it seems like I have not gone over 250 milliseconds. The longest is 248. I mean, it will vary by each time, but it will probably be about the same. So yeah, that's my new algorithm to solve this problem. Thank you.